In this video, we will practice simplifying and evaluating trig expressions such as these, and we will use these sum and difference identities to get the job done. Oh, don't forget about tangent. Kabam! In fact, when you look at problem number 19, and then you look back at the tangent formulas, you'll notice that they look suspiciously similar. In fact, this is the tangent of something minus the tangent of something. That's like u and v. Alright, so it's almost as though this were a u and this were a v. Let's see if the pattern continues to hold. And then in the denominator, I have 1 plus tangent of u. 1 plus tangent of u times the tangent of v. Oh my gosh, it's the same exact thing. So that must mean I can go in the other direction as well. So if this equals this, then that means this must equal this. So I'm going to take an expression that looks like this, and I'm going to write it like this. So I'm going to write the tangent of u minus v, but of course the u in this case is 10 pi over 9, and the v is 13 pi over 36. Now, what can I do with this? I need like denominators, yeah. So if I multiply this by 4, then that would give me tangent of 40 pi over 36 minus 13 pi over 36. So that is going to be the tangent of 27 pi over 36. Both of these are divisible by 9. If I divide both of these by 9, I will have tangent of 3 pi over 4. Alright, just divided both of those by 9. Now, is this something I can evaluate? Well, we have memorized the special angles, of course. I'm going to show you this chart one time, and we will not speak of it again, because you best have memorized this by now. If you have not memorized this chart, pause the video right now and memorize this chart. But anyway, what were we talking about? Oh yeah, the reference angle here is pi over 4. Okay, the reference angle is pi over 4. And we know that the tangent of pi over 4 is 1. So that means the tangent of 3 pi over 4 is either going to be 1, it's either going to be positive 1 or negative 1. Alright, those are the only two choices. And that just simply depends on the quadrant. Where is 3 pi over 4? Okay, well, consider the unit circle. You know how pi is over here on the left? This would be the same thing as having 4 pi over 4. Do this in your head. 3 pi over 4 would be 1 pi less than that. So that means 3 pi over 4 would be just a little bit above this. So clearly this is quadrant 2. Tangent is negative in the second quadrant. So we'll go with negative 1 instead of positive 1. This is too crowded. Oh, there you go. So that's the answer to number 19. Okay, number 20 is basically the same problem, so I'm going to do it a little bit faster. So this is the same thing as the tangent of 55 pi over 18 minus 11 pi over 9. Alright, it's just like the previous problem, except now this is u and this is v, and this is u and this is v. Remember, I know what sign goes in the middle because looking at the formula, the sign in the middle matches the original sign of the problem. The sign in the numerator matches the original sign of the problem. So if I see a minus sign here, I know it's going to be a subtraction problem. So, anywho, I need like denominators, yeah? Yeah. So if I multiply this by 2, then that's going to give me tangent of 55 pi over 18 minus 22 pi over 18. So that's going to be 33 pi over 18. Both of these are divisible by 3, don't you know? So if I do that simplification, that's going to be 11 pi over 6. Alright, love to see that 6 down there. That tells me that the reference angle is in fact pi over 6. Now, we memorized that the tangent of pi over 6 is radical 3 over 3. So that means the answer is either going to be radical 3 over 3 or negative radical 3 over 3. The way I know which one it is by looking at what quadrant we're in. Okay, we're talking about a reference angle of pi over 6. On the left, this would be 6 pi over 6. And if I went all the way back around, that would be 12 pi over 6. So, where is 11 pi over 6? That is just one short of 12 pi over 6. Alright, it would be right here in the fourth quadrant. Tangent is negative over here. So, this is the answer. Okay, if it had been in the first quadrant or the third quadrant, I would have erased that negative sign. Okay, whatever software generated this worksheet really loves this tangent program, tangent formula. Anyway, so I'm going to do this much faster. So this is identical to the last two problems, so probably no one's even watching this right now, and I'm talking to myself. So I've got the tangent of this minus this. I need like denominators. So that's going to give me the tangent of 4 pi over 18 minus pi over 18. So that's going to be the tangent of 3 pi over 18, which reduces down to the tangent of pi over 6. Well, that's just plain radical 3 over 3. That's it. We just know that that's what it is. Okay, sheesh, finally one that's not a tangent problem. Sine, cosine, cosine, sine. Is that the pattern of the sine of two angles or the cosine of two angles? Well, it's the pattern of the sine of two angles. Look, check it out. Okay, or a little technical difficulty there. So when I have the sine of the sum of two angles, it goes sine, cosine, cosine, sine. Alright, and notice that the sine right here and the sine right here are the same. So, for this problem, it is minus. So this is going to be the sine of something minus something. And the two angles are right here. Alright, this is one of the angles, and this is the other angle. So I will have the sine of 23 pi over 18 minus 11 pi over 18. Okay, so that means I will have the sine of 12 pi over 18. Now, both of these are divisible by 6. So if I divide both of these by 6, I'm going to have the sine of 2 pi over 3. Alright, now, of course, looking at that denominator, I'm happy to see that the reference angle is pi over 3. I know that the sine of pi over 3 is radical 3 over 2. So that means the answer is going to be either radical 3 over 2, or it will be negative radical 3 over 2. So to find out which, I need to think about what quadrant 2 pi over 3 is in. Okay, of course here on the far left, this would be 3 pi over 3. On the far right, it would be 6 pi over 3. So where is 2 pi over 3? 2 pi over 3 is 1 less than 3 pi over 3. So it would be right here in the second quadrant. Sine is positive in the second quadrant because it's a y value, and y values are positive above the x-axis. So I will erase this minus sign, and this will be the answer. Alright, number 23 is, I see sine, cosine, cosine, sine. That is how the sine sum formula works. So this is going to be the sine function. And the two angles involved are this angle and this angle. So that's why I'm going to have the sine of 5 pi over 18 plus 7 pi over 18. If you add these together, you get 12 pi over 18. So this will be the sine of 12 pi over 18. Then I'm just going to reduce this. These are divisible by 6. So this will be 2 pi over 3. Now the reference angle is pi over 3. So keep that in the back of your mind. The sine of pi over 3 is radical 3 over 2. So the only question is, will it be positive radical 3 over 2 or negative radical 3 over 2? And that's based on the quadrant. Again, 2 pi over 3 is in the second quadrant. All right, this 2 pi over 3 is right here. That's the second quadrant. And sine is a y value. Y values are positive up here. So that's why I'm going to put positive radical 3 over 2. Did not quite mean to erase that. So this will be the final answer. Whoa, number 24 is pretty much the same thing. Sine, cosine, cosine, sine. That's the sine function again. So this is going to be the sine of 5 pi over 18 plus, all right, because of that, pi over 18. So that's going to be the sine of 6 pi over 18. So that's going to simplify down to the sine of pi over 3. And the sine of pi over 3 is radical 3 over 2. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.